Hello and welcome to the Friday, January 17th, 2025 edition of the SANS and its Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Today's Internet Storm Center diary is coming from one of our undergraduate interns, Curtis. Curtis is writing about how to store data collected from the Honeypot efficiently in a SQL database. The reason Curtis investigated that was to build dashboards for his Honeypot using free cloud resource. And of course, then you're limited how much data you can store in a database. This actually opened up some old wounds in me developing the Shield Internet Storm Center 25 years ago. I certainly made some wrong choices back then that still haunt me today. In some displays of IP addresses, for example, on the Internet Storm Center website, you may still see the octets zero padded, which is utterly wrong and bad, but that was my quick workaround to be able to store data in, 15-character chars in the database and still being able to efficiently sort them. Way better way to store IP addresses in any kind of context is usually an unsigned integer. And actually, most of our data has been switched to that format. And then also things like subnetting and such, of course, become a lot more natural compared to doing it in a string. There actually still a couple sort of IP address handling libraries that don't do that correctly. I think, was it last year or year before last year, we had some vulnerabilities in Python network IP address management libraries that did exactly that same mistake where they treated IP address as a string and then try to do like regular expressions and things like this for subnetting, which of course tends to fail because of all the different ways how IP addresses can be displayed. So interesting diary if you're looking into optimizing, storing log data in databases. I'm sure this doesn't just affect SQL, but a number of other databases as well. Then we have an issue that came up with Microsoft's patches from this week. In particular, if you're running the Citrix 2411 session recording agent, it will prevent the update from being applied. Well, there is a pretty obvious workaround here. You disable the session recording agent, apply the update, and then re-enable the session recording agent. Citrix published a knowledge base article with additional details, how to also update at scale and roll out this particular procedure with PowerShell and such. So I'll link to that knowledge base article in the show notes. And to end the week with, we have another Ivanti advisory actually covering several of their products. There are 4 critical vulnerabilities in their mobile device management tool. They're all absolute path traversal vulnerabilities that allow unauthenticated attackers to then read sensitive data. We also have in their CTA product buffer overflow that could be used to execute arbitrary code. So double check. There are a number of different Ivanti products affected by these vulnerabilities. Make sure they're all up to date. Well, it's Friday again, and I have another SANS.edu student with me, Rich Green. Nice shirt, Rich, but can you introduce yourself, please?
Absolutely, Dr. Ulrich. Thank you so much. Rich Green, I just completed the MSI SE program through SANS.edu. I work for SANS.org itself as a senior solutions engineer, as one of my day jobs. I also, as of this year, took over authorship of SEC 301, the Introduction to Cybersecurity course through SANS, and I will be slowly transitioning to assist with co-authoring, taking over authorship of SEC 275, right? Everybody that knows Rich knows I'm really big into foundations and the baseline, so why not put those 2 courses under my purview?
Yeah, and actually that's also a little bit what your paper was kind of about, in terms of that foundation 301, I'm sure you'll cover some of the topics in your paper. Passkeys, I mentioned them a few times in the podcast before. Big fan. Can you just introduce a little bit about what problem passkeys are trying to address?
Absolutely. I think for me, when I looked at it, I was like, when we look at doing our research paper, it's like, what is something we want to try to fix in the community? What can we provide back to the community to try to help the community out? We all know that passwords have been around for absolutely forever. And we all know, and we continuously say it over and over and over again, that passwords still seem to be one of those weakest links that we have. But it's like, we just learned to kind of accept it, and we'll make it more complex or longer or special characters. And we try all these different things to massage that in there, but it still comes down to it. It's still the weakest link. Passkeys, I believe, again, my thoughts and look at the research, are one way we can look at trying to almost remove that weakest link. For those that are not familiar, passkeys use a key pair, private public key pair cryptography, instead of like a simple known secret phrase that you provide. So it alleviates a lot of that, right? There's nothing clear text going about. When a user is trying to utilize a passkey, they're not putting in a password, they're not being asked for a password. It's a implementation that's happening in the back end between the server or the service and the passkey itself, or the either the password manager or the device, however the passkeys are being stored for that individual. And that's happening. So I think it kind of alleviates, credential stuffing, password spraying, expose hashes, data breaches, all those kind of things.
Yeah. So you mentioned a little bit sort of how it works. And I think one of the geniuses is also kind of that it hides the complexity from the user. It makes it relatively easy to the user. But for us more technical people, if I'm sending a passkey to a website to authenticate myself, how is this different from a password? If this passkey that I'm sending to the website is being leaked, is this different from a password being leaked?
Absolutely. And when I was going through and doing my research, I think for me, what was really cool for those that may or may not be familiar with it, it reminds me a lot of Diffie-Hellman and how Diffie-Hellman works when you attempt go to a website for the first time, right? There's a mathematical problem going on between your machine and the server, right? Some data is, of course, transmitted across the open wire, which can be, captured or sniffed out through that. But the overall math that's being done is protected from being sent clear text, which I think is phenomenal. And that's one of the things I think protect it right there is that complex math that is happening. It isn't really sending my private key across the net to the servers, and it's not sending the public key back to me. On the server's side of the machine, it does some math. On my thing, it does some math, and it transmits the I'm not sure the word I want to use, the solved solution, right? They come up with a math problem that only my key would be able to decrypt. And that's how it verifies my authenticity. Yes, we push this over. We have the same number. Omnis Dominus, you're allowed to play.
Yeah. So basically, you're only sending the public key. The server then encrypts the secret using the public key. You need the private key to decrypt it and send it back to the server to authenticate yourself. What about privacy? Like if I use the same passkey, particularly if I have a physical implementation like some YubiKey, Google Titan or whatever, can websites collude to actually then figure out I'm the same user if they compare the key material I'm sending to them?
That's honestly actually a really good question. And I would actually like to dive into that research myself, Dr. Ulrich, actually, because the implementations I've seen from passkeys, and again, we're going to use software-based passkeys compared to a physical key, like say your YubiKey. I don't have the answer for that one for YubiKey. For the software-based, I know in 301, I preach quite often, we should have a passkey. It's almost the same thing we do for passwords, right? Because we're still using passwords. You would want a separate passkey for each service area you're utilizing to help break down the not complexity, but the cause or concern of it being compromised, if that makes sense.
Yep.
As far as a physical passkey, I actually have to dig into that.
Yeah. Yeah. And that's sort of one of the concerns that people have with authentication is privacy. And that's always the problem we were fighting in information security, the balance between privacy and security. I want to know who you are. But then again, you don't necessarily want me to know who you are. But so that conflict is always a little bit difficult. Do we see passkeys being implemented at this point?
Passkeys are being implemented. And again, it's one of those things. I mean, if we look at it, FIDO2, which is what the whole passkey thing is kind of built upon, has been around. It's not a new technology, right? It's been around for a while. It's the implementation process. As we mentioned before we started recording, if we go back to old FIDO2, it was device bound. Device bound doesn't work for the vast majority of people. So they kind of lax those standards, as you mentioned, which allows it to be more, we can use password managers to store passkeys and whatnot. So we create the ability to have more scalability and flexibility. They are being implemented. Microsoft, Apple, Google have really made a big push. Most modern smartphones and devices being created nowadays have the technology to implement it. And I think that has always been the biggest hurdle for the implementation of passkey as a technology is legacy software or legacy hardware. Yeah. So if we look at large enterprise organizations who have invested millions and not billions of dollars into a network infrastructure, the cost for them to kind of like make that transition might not be cost effective. And that I think is the biggest hurdle is the legacy implementations of it. But it is definitely being used. I mean, if you log on to most websites nowadays, if you go to, Gmail or Amazon, they'll all start asking you, hey, would you like to set up a passkey for this?
Yeah. So, is it usually an option then? You can either use traditional passwords or a passkey, depending on what your preference is at this point.
That's what I've seen so far. I don't think I've seen a single website kind of put it out there like, no, you will only use passkeys. So far, it's still kind of like here's this option, which we think is better, but here's this other option you can continue doing. Yeah. And then I also think about it from the fact of, and I'm going to use big tech, kind of like big pharma here. Passwords have been so paramount and integral in kind of InfoSec or network security for how long? I'm curious how long they will try to hold on to that or like slow down the implementation of the passkeys. On the security side, we should do it. Absolutely. But I am curious about that one myself.
Yeah, excellent. So the paper is in the SANS.edu cybersecurity research section. If anybody wants to see a little bit more of a deep dive into passkeys, take a look there. Any final words?
Take a look at it. If you have questions, if you are listening to this and you're like, you know what, I am an expert in passkeys or FIDO2, I would love to talk to you. That is kind of my biggest thing is I definitely am very passionate. And I think if we can kind of negate the password issues that we have right now with a different implementation, I think that would solve a lot of problems that we have. And in our world, there are a lot of problems we have to deal with already.
Well, and that's it for today. Thanks, Rich. Thanks, everybody, for listening, and talk to you again on Monday. Bye.